All right. So as I mentioned, this is just a quick review of basically everything that we cover in our JavaScript pre-work. So the hope is we're going to cover all the fundamentals of JavaScript, talk about like the very basics all the way through data structures and functions and looping and all those things. And depending on time, also some DOM and events. So right now I have a few things I wanted to just go over with y'all. So I'm in my terminal right here. We can actually do a lot in here. And if you all have your environment set up, you should be able to actually open up a node environment here will allow you to run JavaScript in here. So just real quickly, if you type node while you're in your terminal, you'll actually open up this little environment. And this is actually JavaScript. It's a JavaScript environment, which means you can run JavaScript things like expressions and stuff like that. So I'll be doing a lot of work in here and just kind of going between VS Code and this because this is very handy for like running short tests and short snippets of code for us. So I'm going to clear this. So this is just again, the node environment, even though it doesn't say anything on top now. Cool. So let's start. So in JavaScript, we got a whole bunch of things to cover. The first thing I want to talk about is expressions. So we have a few expressions here that are some basic examples. Expressions are basically any sort of line of code that is evaluated. So in this case, and also that returns something. So we have some basic expressions here. These are all constant expressions, which means they evaluate to what they are. So if I were to go back to my terminal and a node, I can say like 5. 5 returns 5. 10 returns 10. True returns true. We also have expressions that are evaluated to something else. So in this case, we're actually providing an expression that is a mathematical expression, 2 numbers added together. So we should get 10 in this case, because this whole thing is an expression that we are evaluating, and it's returning the actual value that this equals. Same with other things like this example here. We can add strings together, and it will string them together into a single thing. Notice I added a space here as well, because otherwise it'll run it together. Other expressions you'll see a lot would be things like comparisons. So here we have like a comparison expression. So I ran this in the terminal. It actually doesn't return any value. It returns, or a number, it returns true, because the expression is actually this whole thing. It's saying, is this number greater than this number? This evaluates to true. Same with other comparison expressions like triple equals. Can you all tell me, while I have you all here, what the difference between these two lines is? The triple equal and the double equal?
One is loose and one is strict.
Yeah, exactly. So if in this case, this first line, we're saying is 5 strictly equal to 5? And that's true, right? But if we say is 5 strictly equal to the string of 5, it's not going to like that. It says false. However, with 2 equal signs, it comes up as true, because we're saying actually this is the strictly equal, and this is the not so strictly equal. Yeah. What was the word you said? I'm sorry. It was strictly and you used a phrase.
Loose.
Loose. Yeah, exactly. Yeah. Strictly and loose comparison. So yeah, this is, you can use either one. We do tend to encourage you to use this one because it's just more like it's possible you might have matches here that you don't intend, unless you really want to compare a string to a number for like this. It's often good to do the triple equal just to make sure what you're comparing is really what you want to compare if you're trying to see if they're equal. Of course, there's other operators. So like you can do things like not equals. Similarly, not equals also has actually its own loose and strict checks. So I can actually say something like, if I say with 1 equal sign, string 5 says, well, the number 5 is not equal to the letter, the string of 5. It's actually false, but that's not the, so I should clarify. It's saying it's false because it's the opposite of this. It's the loose operator, and we're saying, are these not the same? We're actually, and in fact, they are not the same. Does that make sense? Does that make sense? Apologize. But that's just different from running this, which is 5 is not the string of 5. But in this case, 5 is not the string of 5. Well, they actually do, since it's a loose comparison, they actually are equal in this check, but they are not equal in this check. So this is not the same. Okay, cool. Unless there's any questions, I'm gonna just keep jumping through this. So those are some basic expressions. One of the things that we get that's most useful about expressions is that we can actually store things like expressions in variables, like these variable assignments here. So we can do things like store strings in a variable. We can store all kinds of things in a variable. Here's another example. And then we can actually recall them, say example and example 2. And they'll store whatever value you put in there. Can anyone tell me what the difference between these variables might be?
The var is the old one, right?
Yeah, this is, the original.
So yeah, basically the let one is more, it's called loose also. You can change it. You can change the variable.
Yes.
The mutable and immutable? Does that work?
Yes.
Thanks, man.
Okay.
And the const one is the consistent. So you cannot change it.
Yeah. It's short for constant. Yeah, exactly. So if I, just to confirm that, I can say like, hey, we've assigned this example 2 to high, but let's say I want to change it up and say bye. Well, now it's just equal to bye. If I try to declare it as example 3, good day. If I tried to redeclare this one or reassign it to something else, I'm going to get an error because it will not let me override this. So yeah, as Edmar was saying, basically, in general, you would use these 2 variables. We try to avoid using this. There are some use cases, but it's beyond the scope of pre-work, really. Did someone have a question? But we tend to use these ones, and we use let when we want to declare something that we want to change potentially. And otherwise, it's generally we use const. So you'll see in these examples, I'm using a lot of const because I'm not planning to mess with these at all. And so by default, I just tend to switch over to const as good practice. Cool. So we have the 3 basic variables, and we typically use let and const as much as we can. Variables can store a whole bunch of different data types. So one of them you've seen already is strings. And we have a whole bunch of different types of strings you can actually create. So you can create strings with double quotes around them, or single quotes, or backticks. These are all valid strings, and they all will just evaluate to strings when you store them. The one reason why there's a little bit of difference is that you can use backticks to interpolate. So in this case, I'm actually taking some value that's a variable. In this case, it's up here. It's this high variable, and adding it into the string. And by wrapping it in backticks and placing the variable in the structure, the $, curly braces around it, JavaScript knows like, hey, this is actually supposed to be evaluated, and evaluate it and then make it a string and return that entire thing. So if I were to run this just in the console, since I already have declared this example that's going to be in my variable, if I run this, it's actually bye because I changed it to bye up here. I could do whatever I want here. I could actually say any sort of expression in here. So if I wanted to say 5 plus 5, 5 plus 5 evaluated as 10. So I can interpolate that into a string and say 10 o'clock. Cool. So string interpolation, all of these are fine, but if you have to add a variable into the string, you want to use interpolation. You can always do the manual way, which would be something like adding strings together. So for instance, hello plus example 2. So it actually is taking a variable and it knows like this is a string. So it's just pushing that string to, it assumes that this is going to be a string too. It will just push them together into a single thing. Of course, I want to do a space so that way I part a little better. Or hello, I'll clear this up a bit. Hello. Can anyone tell me what's happening here? Why isn't this adding?
Because it's still reading it as a string, basically. So
yeah.
Because of that hello.
Yeah, exactly. The JavaScript does its best to do whatever you're trying to do. It thinks you must want to do that. And so it will just not error out. It'll say, okay, you probably just want these things added to this string. So if you see something like 1, 2, and 3, that's all mathematics. It'll add them all together. It knows these are just addition. But as soon as you add a string, it'll keep adding until it gets to a point where it can't add anymore. And then it will say, okay, you're trying to add this number 6 to 4. So you get 64 as a string. And once you're a string, you're always a string. So it's just going to keep going and add these as string characters as well. Of course, this is all dependent on, if you're familiar with like PEMDAS and parentheses, you can do things like this, which is what happens here is actually we're adding these together plus a string, but this evaluates first to 10. So actually it ends up being a 10 as a string here. Okay, cool. So just a few more data types I wanted to talk about real quickly. We've got numbers, which we've seen a few of already. Just to note, numbers are in JavaScript, they're all just numbers. So you can do decimal points or integers, real numbers, or whatever they might be called. In some languages, you might see that these are actually two different distinct data types. JavaScript, they're not, they're all numbers. One other thing you often see, and we've seen already in evaluation, is Booleans. So Booleans are their own data type, and they are just true or false. So you can either write true like this, and that is a Boolean, or you can actually get Booleans from evaluating things. So this becomes a true or false value, evaluates to it. So yeah, those are some of the basic ones. Some things we'll talk about in a moment too, in more depth. Some data types where we store other data, often called data structures, are arrays and objects. So an array is anything that's wrapped in these brackets like this, square brackets. And that means that's in JavaScript denotes the shorthand effectively for arrays. And you can add stuff while you declare it like this, very simply. Or you can do other commands, which I'll show you in a second, but we'll jump back. Actually, I'm going a little ahead of myself. One thing, if you're ever curious about what data type an object is or a thing is in JavaScript, you can use type of. So in this case, if I go to my terminal, I use type of true, I'm going to get a Boolean. Type of hello, I'm going to get a string. You can even do things like compare. So I can say type of, you can even, our previous example where we're adding a number to a letter. So we can verify it's a string. You can see, you can do these things like that. You can even evaluate and it will tell you, but notice the parentheses here. These parentheses are there because we're saying actually evaluate this first, and the result of this expression is what we want the type of. So the result of this whole thing is a Boolean. You won't get the same result if you try to do this, or even this. So like, this is kind of strange. It looks like, well, 1 does strictly equal 1, but what's actually happening is JavaScript's reading from the left to right, and it's saying, what's the type of 1? Well, it's a string. Does string equal 1? No, it does not. Or I'm sorry, what's the type of 1? It's a number, which is number is actually string, and that's false. So what happens is JavaScript will just evaluate from left to right unless there's parentheses that that will cause it to evaluate those first. Any questions about any of that stuff before we jump to the next thing? Okay, cool. So please stop me if you have any questions. I want to go on to just some conditionals. So I'm going to load up these two in Node here. So we just have first number and second number. Cool. What happens if I run this conditional? Is this gonna get called?
Yeah.
Sorry, you cut out a little bit.
It should get called, yeah.
Yeah, exactly. So, yeah, this is a standard if statement. The way if statements work is you have an expression that you pass to the if statement, and this evaluates typically to truthy or falsy things. So in this case, we know this is actually evaluates to true. Sometimes things might be a little less clear. Like for example, if you evaluate undefined, what is undefined? Is it true or false? It's actually really neither, but it technically evaluates to a sort of falsy value. So if I were to run this, it doesn't run it. It doesn't actually do anything. If I were to actually pass it, like a statement we know always will pass, like true, it will. You can see it's logged the message. It still returns undefined because this statement doesn't actually evaluate to anything, but it does log here. So why in this case, like undefined is not actually equal to false, but it's one of the few values or data types, really, it's its own thing in JavaScript that evaluates to falsy. One thing you can always check, you can run is Boolean. Oh, I think it has to be capital B. If you wrap like a value in Boolean, it will convert that value to truth or false. So because this is technically falsy, when you wrap it there, it'll turn into a true false value, or an actual false value. Another thing you might see, kind of a shortcut you'll see in code, is you've probably seen in the comparisons, you've seen this exclamation point. Like when you say exclamation point equals, it's the not of strictly equal. This can actually be placed in front of values to negate that value. So this evaluates to falsy. This exclamation point then says, well, do whatever the opposite of that is. It's falsy, so now it's truthy. Now if I run this, it's going to log it because now it's falsy, but reversed, okay, like Uno reverse, basically. You could even stack them in front of each other and do that, which is actually the same as wrapping it in Boolean. Because what you're saying is evaluate this, then do the opposite, and then do the opposite. And it will always return a Boolean value the same way that running Boolean will do. Both work. You just often see, this is often a sort of shorthand you'll see. Cool. So standard conditional statement, based on the evaluation of the expression, it will call the code inside of it. So what this is often referred to as control flow. So what you're saying is JavaScript will read code from the top to bottom. And as it reads through here, it will decide basically what to do based on these conditionals. So if it reads line 1, it declares first number and defines it as 5. Line 2 declares second number and defines it as 20. And then it gets to here and it's like, well, whatever this does, if this was undefined or false or whatever, then skip. So in this particular case, this code will just never run because false is here. There are also situations where you'll often want one choice or the other. So like this is an example of that, and that's when you would use an else statement. So if this evaluation is true, then do the first thing, otherwise do the second thing. So here we know first number is 5, second number is 20, so we should expect this not to fire, but instead we should see this. So we run that in terminal. False. Just to confirm, to avoid any confusion, I'll make this a string because these are, don't want to confuse you that that might be returning something that's false. Is actually just logging whatever is in here. Cool. There's some other options like switch. I won't go into those. Often what I'll do if I need to use a switch, I'll still look it up on like online to get a reference on MDN so that I know the syntax. It's pretty rarely used. Usually if statements are good enough and often and sometimes faster in terms of speed and performance. All right, so next thing is functions. So here we've got a number of functions. In short, just to quickly summarize, functions are effectively code blocks that you can store work in. So the idea behind a function is once you define it, you can call it as many times as you need. And ultimately, this is a huge backbone to general programming of all programming languages that are popular right now. Basically, we can write functions that become very useful across an entire application and run whenever anything calls it. We don't have to keep writing the same code over and over. If we wanted, for instance, to log this throughout our application, we could just call this function as much as we want. So a basic function in terms of structure always starts with the function keyword. This is a reserved word in JavaScript. Then it's followed by the function name. This is just like the what will actually, once it's declared, this will be what we can use to access it. Functions always include this little parentheses here, which will make more sense in a moment, but this is in the definition, it's where parameters would go. And when you call it, it's also the indicator that you want to call a function. And then after those, it's going to be curly brackets containing whatever code you actually want to run. Good habit would be to have a semicolon there if you had a bunch of things in here. But yeah, the idea is everything in here will execute when you call this function. So if I were to load this up just to confirm and try to call example function, you'll notice like, hey, we see that this is defined as a function. So it's actually trying to return that to us. But that's because when we write out this without the parentheses, it will actually try to just return whatever that definition is. In this case, it would return this. Node doesn't do that for you, but it's wanting to return the definition of this function. By placing the parentheses at the end, you're actually saying, call this, whatever this is equal to, call it. And there we can see it's console logged hello from this example. Now I'm going to load up a different function here as well. So these are both loaded up. What's the difference between these two functions? Can anyone tell me?
One's actually returning something.
Yeah.
Log is just going to tell you.
Yeah, exactly. This is just logging. So we just saw that. It's going to just put out this thing into the console, or in this case, node. But that's all it does. It doesn't actually do anything in terms of like values or work. It just is logging. This actually returns that string. So we can see if we'll call example function again. We see hello from this example, which is the log. And then we see undefined, because this function actually doesn't return anything at the end. So it just is undefined. It doesn't have any return value. However, if we run another function, we now, instead of logging, we get the actual value. And you can notice in Node, at least, it's designating it by like, hey, this is a string. This is just a log because it's just output in the terminal. In this case, it's actually a value that we're giving back. And there's no undefined because this is the return value. So I'm going to do a quick quiz. Well, jumping on to the next thing, we have functions with parameters. Functions can take arguments in or parameters in that we can then do work with when we call them. So in this case, we have this function called add two numbers, and it takes in two things, num1 and num2. By accepting parameters like this, we can do more abstract work. So you could have a function, for instance, that's like add two numbers, and this returns 1 plus 1. That's a function. It certainly is valid, but it's not very useful. Instead, we could do something like return num1 plus num2, and then pass in whatever values you want. So now instead of this function that does this one thing, we now have an adding calculator that does everything. Every two numbers will add whatever we want. Whenever we give it, it'll add it together. So we could still replicate our first function here by doing something like that. We can say, oh, sorry, I made a mistake here. I'm gonna fix my function name. If we call add two numbers and we pass 1 and 1, it's going to do the same thing as this function. It's going to say what happens when we call it is this becomes 1, the first argument, and this one becomes also 1, the second argument. Let's just change this for clarity. So now this will actually return 3, just to make sure they don't get confused about the two numbers. So this first one is whatever argument you pass in, and when you call it here, and the second one is the second one here. And by adding those together, we get 3 again. But now we have this variability in our code. We can now keep calling this and doing whatever we want, and it will always return this work. Whatever these values are, it'll add them together and return them. So I'll just call these to confirm. 3, 4, 103, etc. So what we've done is abstracted out some code that we could have hard coded it and gotten the same result if we only needed this one result. But now we have a very useful function that will do addition for us.
Does the end of line 15 need a semicolon? Because it looks like it worked without it.
Yeah, semicolons are technically optional. They're just good practice because they do designate the end of a line. But if JavaScript if you're making sure to make line breaks, JavaScript will interpret each line as its own expression. So you don't always need them.
Okay.
One reason why semicolons are useful is you end up writing functions that are like pretty small. Maybe you want to have a function that's, if you want to, for whatever reason, want to get it on a single line. You could say console log hi, put a semicolon, and then say console log hi, semicolon. This, if you run this function, I'll load this up. And single line, it'll log both just fine. However, if I were to remove this, that would no longer be valid because now it's like, this is an expression, got it. I don't know what to do with this. This isn't the same line. If I redeclare this, it already doesn't even let me. So it's like, you've put in some things here that aren't right. So like semicolons they're very helpful for saying, this is a line and this is a line. And I think, Joseph, I saw you raised your hand. Do you have a question?
Yeah, I'm kind of surprised that you were able to put out two functions with the same title and it didn't throw an error. Does JavaScript just notice that you have arguments in one and it just calls right one if you put arguments in it?
That's a great question. No, it actually just goes based on order. So in these two functions, they are named the same. But what JavaScript does is it says, okay, you're declaring a function here called add two numbers, great. And then it goes on and says, okay, you're declaring a function called add two numbers, great, this is now the function. So it just, this
So
will,
you're just redefining it. When you wrote it out a second time, you redefined the function.
exactly. You're just redefining it. Yeah.
Okay.
Yeah. There are a few other ways you can declare functions that like will prevent you from doing this, but those will be more for like phase one. Where if you can assign functions to variables, for instance, and if you assign it to a const, it will like stop you if you try to reassign it. But yeah, in this case, functions defined this way, they'll just override each other based on whatever's last will become the function if they have the same name. And that's actually very good to keep an eye on too, because you might be working through a problem and realize that you've overridden part of your solution by just not naming your functions different things. Great question. The last function I want to talk about is just with default parameters. So in this case, we have this function that's, oh, someone have a question? So we have default parameters here. In this case, we have a function that takes in a variable day or a parameter that we'll call day. And it has this thing here at the end, equals Friday. If we run this function, or first let's run it in Node to define it. Example with default value. If I just if I say this, it's going to say, hey, today is Friday. That's because by providing this equals to something, a value here, this becomes the default value of this parameter. So if I don't pass anything in, it'll just default to whatever that is. But if I go ahead and pass in another value, it'll overwrite that default to be whatever you provided. Definitely very handy if you are not sure like what you are going to get in your function. You might have a function that's called in different places, and you want to make sure that at the very least it runs this default behavior. Then this is a great way to do that. Cool. Any questions about functions? Awesome. Cool. So I'm going to keep going. I'm going to jump over to data structures. So we saw some already. We saw some arrays in the initial data types conversation. Here's an example of an array of a bunch of different things. Arrays can store all kinds of data types, and there's no issue with them storing them together. Some languages will actually give you an issue with this kind of thing, but not JavaScript. It's very friendly, tries to do its best. So here's some strings, and then it's a number, another string, and a Boolean. This is a perfectly valid array in JavaScript. If I declare it, I can then access it again, of course, and it outputs all the things here. If I want to get to a specific element, we can provide an index for it in the square bracket notation like this, and it will actually output that element. So in this case, now that I have array loaded up in my node, I can access the first one by 0. 0 is always the first element in a list. I can access, of course, the second one by 1, 2, etc., and it'll just go through the list. What if, can anyone tell me without using the actual index, how I might get to this value, the last one?
-1.
Yeah, array, -1. Oh, wait.
Shouldn't it be?
Length -1.
What was that?
Length -1.
Yes, exactly. So length is a property of arrays, which we'll go into more in phase 1, but this returns the length of the array. So in this case, 5. And if I return array a length -1, I actually get 4. But if you remember that arrays start at 0, so this is actually the fourth, the index 4 of this array, which means I can say array.length -1, and it will return that last value. If I said the second to last value, -2, it will return hello. Of course, there are some other ways we can get these values. What happens if we wanted, let's say we wanted to get this true value out of the array and modify the array. Does anyone know how we might do that?
Splice or slice.
Yeah, you could do that. You could do something like array. So slice, I believe, takes in the initial index and then returns and the end index. So in this case, we do like 4. It actually returns an array in this case. Splice does not seem to return anything at the moment. What's another way though? There's actually some methods built into array that we can get things off of either end of an array with.
Is that the dot assign?
Nope, not assign.
Okay.
Oh,
Pop, yeah. Pop. We'll actually return that last value. And if we write array again, it actually popped it out. So I'm just curious if we do splice 3. So splice actually does a similar thing. It took out this one. And it actually changed the array. Whereas if I did slice, now since I'm reducing, I'm going to go to 2 because I'm going to cut the last one out. It returns 4, but if I run array again, or get the array again, it hasn't changed the array. So you can notice here, pop modifies the array, splice modifies the array, and they return values. Although they're slightly different, pop will return just the value, splice will return a new array with any values in it. And then slice will also return a new array with values in it, but it will not modify the original. So this is the difference between destructive and indestructible. Actually, what's the word for the other one? Destructively?
Non-destructive.
Non-destructive. Thank you. Like undestructive? That doesn't sound right. Yeah. So pop will pop off things from the end of an array. We can also, of course, push things onto the array. So if we give it a value, it'll actually. Do y'all know what this number is? Why is it returning 4 here?
It's the very last number in the array or value.
That's a good guess because that's a good guess because it's here, but it's actually returning the length of the new array. Because now, whenever I push, let me give another example. Hold on, I'll say true. So right now we have a true at the end. If I push something else, false, I'll get 6 because the array is actually the length 6. There's 3 and 3, 6 things total.
So it doesn't return the index number.
No, it does not. It returns the length. Yeah. And then, of course, though, since it's modifying the array, then you can use that same variable to then access the newly changed array. There's other ones, of course. There's a shift, which will pop off the very first item, and it will be destructive. So it will take it out, and the array will change. Of course, if you just wanted to get that element and not destroy anything, you can also access it in this way, for example. Cool. Okay. So there are more methods on arrays. There's lots of them. We'll go into a few more later on, or mostly in phase 1. Now I want to jump over to constants. Over to objects. So here's an example of an object. So we know we can declare objects by just doing the curly braces like this. Objects also have things in them. It's effectively like, you can think of objects almost like a dictionary of words and definitions. So in this case, we have what we often call keys and values. So an object has keys that go ahead of a colon, and then a value that's associated with that key. So in this case, we have 2 keys tied to 2 values. And if I create this object, I can now see those values in there. How can I get to this value here? 5 from this object.
obj.5.
Close.
.id.
Yes, .id. Yeah. So there's a few ways you can do this, but with objects, to access a value in an object, you type the object itself, and then you can add the key after a dot in dot notation. So by saying object.id, it returns the value associated. If I write example, it's going to return the value associated here. I can also use square bracket notation similar to an array, but in this case, I can actually pass in strings. If I pass in the string ID, it will also return 5. Because this square bracket notation, it's very similar. What it does, though, is it basically, whatever you give it, it will try to find a key that matches, almost like a loose comparison. But it actually, I believe, does convert it into the thing and knows, like, okay, you're looking for this key. So we can say object example, hello. One thing that's really kind of cool about this is that in this case, you have to use the key. You have to be hard coding ID. In this case, you do not. So if I had a variable called key and I named it ID, I can now say object key because key is ID. So by assigning variables like this, we can actually start to get really abstract, and we can have functions that are like, hey, get this, whatever this ID, this key is out of this object. So if I had like I could have a function, for instance, that said get value, and it would take in an object and a key, and it would just return object key. So it's like whatever object you give me and you give me a key, I'm going to return the value of those two things. So now let's try this out. If I say get value of obj, which we've created, and ID, I get 5. Example, hello. Any questions about this and why this works?
I kind of just want to like clarify something. So when you're using bracket notation, on the inside of the brackets, you would put the keyword in parentheses, or excuse me, in quotes, only if it's the name of a key inside of an object.
Ah, good question. So the quotes are just, yeah, it's like the quotes are just a string. So you're just, all you're doing is passing a string in this case. But the way that square bracket notation operates is it knows if it receives a string, it'll try to check if any keys match that string.
Okay. So basically you're telling it to look for keys when you put it in quotes like that.
Yeah, this is looking literally for the key as one of these keys.
Okay. And then and if you're asking it to just look for a variable, you can drop the quotation marks.
Yeah, so this could be equal to something like a string, but whatever it is, it's just being passed in, and yeah, so you can do, this can be all kinds of things. You can do other data types as keys as well. It's not usually recommended, but you could say something like obj symbol is equal to 10. Oh, it actually didn't like that. I'm forgetting the symbol key. I forgot about that, but you could say like a Boolean, obj true.
Yeah.
If I run obj, it actually says true here, even though that's not a string, it's an object. I mean, it's a Boolean. Let's see what happens if I try true. It does work. So that's kind of funky. Again, JavaScript's like, okay, this is a Boolean. We know it's Boolean, but it kind of matches. So.
Yeah. All right. Yeah, that definitely tripped me up in one of the labs where I was trying to call a key from an object and it kept striking it out. It would give a strike through, and I finally put it in quotations and it was able to find it.
Oh yeah.
So I don't know what's going on with that, but okay, cool.
Yeah, I'm not sure, but yeah, that's it is definitely a thing that kind of can make it pretty tricky if you're working with variables to remember, like, is it a string or if it's a variable? Yeah.
Alrighty, thank you.
Yeah, for sure.
Someone had a question on the
Yeah.
chat, and I was kind of wondering the same thing too. In which cases are dot notation and bracket notation interchangeable, and when are they not?
Oh, yeah, that's a good question. They are basically interchangeable to whatever you need. I mean, the main thing is that since you can't really be very abstract in the dot notation, like you just have to be literal with this is the key I'm looking for. Whereas this, you can potentially have a variable or something else. So basically, it's just whatever when you can use them interchangeably, depending on what your need is. So, like this might be a you could write a more abstract way to do things in this way, just like I just did. That's basically the main difference.
But you wouldn't be able to use dot notation when calling an array.
Great question. So there's a sort of weird thing because you notice here, like we are actually kind of using dot notation here. And there's a secret there, which is that arrays are really objects and they have things on them, which is we won't get into until phase 1. But you're right, like arrays actually do have dots, but you won't be able to say array dot 0. That's not going to work because the reason is because arrays actually don't have keys. They are just a series of values. They are technically a special type of object, but these value types, these values in the array don't have anything, any sort of unique key tied to them besides their number, like this. Yeah. Does that make sense? Okay.
Yeah, thank you.
In my mind, just so I'm clear, like I just want to know, like abstract, foundationally, it sounds like could you use this approach in a way that you would like dynamically show a web page to a different user?
Oh,
is that kind of like the foundation of kind of figuring out the user and then deciding all the different kind of approaches you would take to certain objects or elements within your document?
Yeah. I mean, like an example might be we might have. You'll start to work with like JSON data pretty soon, but you might get an object that represents a person that has like, hey, this is that person's unique ID and their first name. First name. Oh man, is Frank. And basically you could have something that this is very, very simplified, of course, but you might have a check in there that's like if object, or depending on whatever the ID is, maybe display a name, or there's much more complicated situations where you might say a user puts in their information and based on like records in the back end, like, okay, based on this information, I'm going to return you Frank's info. You could say something like, this is very, very simple, but if object ID is greater than 1, return object.first name. That's like a silly example, but you can conditionally define things or display things on a page based on data like that. Does that make sense?
Yeah, absolutely.
Someone else have a question? Okay. Okay, cool. So got some basics of objects and arrays. Again, yeah, you can do bracket notation, square bracket notation for arrays, but you cannot do the dot notation for values. You'll see these though. These are actually they're methods that are on the array, but don't worry about that too much right now. I want to jump over to some nested examples and some looping. So you've seen some basic arrays. One of the greatest things about arrays and data structures in general is that they can be fit inside each other. So here's an example of an array that has 3 elements that are all actually also arrays. So we know, for instance, if I load this up into my node environment.
So that's basically an object.
It is technically an object, but it's a special object that's considered an array. Yeah. So all arrays in JavaScript are technically objects. Also, technically, functions are also objects. But again, don't worry about that until we get a little later in the course. The main thing is just like, can you use these in the way that they're meant to be used? In this case, like we want an array, as we said, like can only be accessed certain ways. It's also arrays and objects are they sort of serve different purposes. So like this array is useful because it gives things in an ordered list, whereas objects will just give you keys and IDs and values. There's no particular important order for this stuff here. So each one can store data. It just depends on how you need it to be stored and like what your use case is. In this case, we might say like, I want to keep this list in this order, which kind of makes sense. Maybe you had a keypad, or you'll often see like challenges with a maze or some kind of like two-dimensional grid here. This is actually effectively representative of a two-dimensional grid. So if I wanted to, for instance, get to the first element, it returns this one. What if I wanted to get the second value in this element? How might I get that?
Nested array example, bracket 0, bracket 1.
Yeah, exactly. Yeah. So how does this work? Well, what we're doing is we're evaluating to like different things. At every square bracket, we're actually evaluating something, and then we're just adding another bracket on top of it. So this first one evaluates to this. We're saying, okay, whenever you run this, it evaluates to this new array. And all we're doing is adding another square bracket to this array. So once we do the two in a row, it can actually go from the like top layer into the next layer in. If we wanted to, for instance, access the last array inside of this array and the middle one, it'll return 8. Or like we said before, if we wanted to get like, if we don't know how long this array is, we could do things like nested array dot length -1. And we can get super complicated if we want to. It doesn't like, actually, I won't go into super complicated. Sorry, it's probably get too confusing than it's worth. But yeah, we can mix and match however we want. Sometimes you might need the very last element inside of the very last element. You can do that with pretty abstractly, even if you don't know the actual index. So yeah, we talked about how to get access values from inside arrays that are inside arrays. And these can go as deep as you want. If there's another one here, we have to go even further, another nest into that if we wanted to get these values. So it would be like nested array example, square bracket 1, square bracket 1, square bracket 0 will get me to 5. All right, cool. So the next thing I want to jump to is looping. So I have another array example here. I'm going to just declare it. And here I got a loop. Can anyone tell me what this loop does?
It's going to add 1 to the array each loop.
It's a good guess. There's definitely this plus here. That's adding to n. With a for loop, all the stuff that happens up here is just part of the loop. It's not actually. It's like the conditions for the loop itself. So what we do when we declare a for loop is we provide the initial condition. So we're saying, hey, we're going to declare this variable n and assign it to 0. We then declare basically what's considered a Boolean, or the conditional statement of like whether or not we're going to call this loop. And then lastly, we're going to increment whatever we declared. So in this case, n is starting at 0. As long as n is less than the length of this array, then run this thing and add 1 to n. So this loop, what'll happen is it's going to run for the length of this array. It's going to run for every element. This 1 time, 2 times, 3, 4, 5, 6, 7. We have a console login here that's accessing this array that we're actually looking at and providing a square bracket notation with n. So we know n is this variable here. And while this is looping, we can see before we actually do anything, let's just see what n is. So what we'll do is something like index. Oh, this is also a useful trick for if you don't know. You can add multiple values in console, and it will just put them together for you. So you can format some of your own console logs a little easier. So in this case, like let's say you do something like this and say, all right, I want for every loop, I want to log the value of n, whatever this is. And then I also want to log the actual value of this array in the index. So if I copy this into my terminal, I'm going to get rid of this. Oh, okay. In my terminal, I now get all this output because the first time it loops, n is equal to 0. And another array example at position 0 is going to be equal to 1. So that is 1. Index is now incremented by 1 on the n++ here. So index is now equal to 1. And the value of another example at index of n now is 2. We'll just keep going because I know there's some numbers that are like kind of replicating just to avoid confusion. Index 2 again, n increments again. Value is going to be equal to 3. Index increments again. So now n++ means now it's equal to 3. It's still less than the length of the array. So what's the value at index of 3? It's going to be true. Increment again. 4 is the index that n is at. Then the value is going to be equal to high. And again, 5 is equal to the array, and index of 6 is yes. That's the entire thing. So if in this case, I just iterated through and output everything in this array. Now I'm going to give you a slightly different challenge. I'm going to use some of the things we've learned so far and see if we can work through this. What if we have this array here, another array example, and we have a results array. How might we write a for loop like this, where we only capture strings out of this array and put them in the results array? So we only want to capture hi and yes. Can anyone tell me how we might approach this?
Would you modify another array example .length to make sure it doesn't go above the max?
Let's see what does that do? So how would you do that?
Let's see. So just stepping back through. So for let n equals 0, so for its first loop, so if n is less than another example .length, run the loop, and then you want to make sure it stops, right?
Close. So one benefit of the for loop is that since you're defining everything here, it will definitely stop, assuming your conditional statement is a good one. Like in this case, it's always going to stop when n is if n is equal to or greater than the length of this array, it will not run the loop. So like this is actually it will only run the amount of times as the length here.
You could start with an if statement.
Yep. If statement. What do we put in that? What do you think we should evaluate for?
Use the type of operator, or yeah. So say if type of equals string.
Yeah, exactly. What do we put at the end of type of here?
N.
Array n.
Close.
Another array example.
Very closer. What do we need? What do we need at the end of this array example?
N.
Yeah, or just square bracket notation n.
Square bracket n. Yeah.
Because what we're doing is we're actually evaluating this expression, saying if this evaluates to something that equals string, the actual string word string, then do something in here. In which case we know that this will change based on the loop. This is sometimes a number. So the first three are numbers. The fourth one is a Boolean. The fifth one is a string. The sixth, or sorry, yeah, the sixth one is no, fifth one. Fourth one is a string. Fifth one is an array. Sixth one is a string. So like we wanted to say no, 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 yes, no, yes. In this case, that's what it's doing. It's going to say typo of this compared to string. And if that's the case, if it's true, then what should we do here? If our ultimate goal is to move things into this array.
Should do console log string something.
Close.
No, return.
Well, we're not in a, that's a good guess too. We're not in a function, so we actually don't have to return anything in this case. If this was in a function, we'd want to return.
We need to use dot push maybe.
Yeah. So all we're doing is like, hey, go through this entire array, and every time it matches, we have this conditional it matches. Just put whatever the value is in the current state of this loop into the results array. So we'd say results array dot push whatever this value is. Now, if we, did I already call results array? No, I don't think so. Cool. So let's get these defined into our node state. So I'm defining an empty array. We already have this other array defined earlier. So if I run this loop, I get 2 because the only value that's actually returned is whatever is from this statement here. But if I try and say results array, now I have only the strings out of that array. Does everyone see how that happens? Any questions about this kind of loop and how that might work? Do you want to
How did you get the 2 again?
Sorry?
How did you get the 2?
Oh, so the 2 is actually the return value of the final thing loop, which happens to be, this is the last line that ran. And if you remember that push just returns the length of an array. So it's like, that's just the last thing that it evaluated to was whatever this is. If we put, I'm pretty sure if it's like, actually, yeah, I'm not sure if I can give a great example of another example, but yeah, it's just gonna, in this case, that's what it evaluated to here.
I have a question about this session.
Sorry?
I have a question about this session.
Sure.
It looks like it's being recorded. I'm wondering, I have to go to another thing, and I'm wondering if this might be available to review.
Yeah, I'm going to share this out to the channel. I'll probably stop recording shortly after this, but I'll share it out so anyone who wants to review, you can check it out.
Okay. Awesome. Thanks, man.
Yeah, for sure. All right. What other examples y'all have? Any other questions about loops?
What if we wanted to log what the actual string elements were in this for loop rather than have the last line of just dot push run? If we wanted to see hi and yes, would we console log?
Yeah, exactly. So we could do a console log here. And in this case, the conditional still applies. So it's like only do this if this particular value is a string, right? So now if I run this again, it'll just console log those 2 things. And you can see here now this time, there's no actual evaluate. There's nothing here that will evaluate anything. So now I get an undefined as the value that it's returned, but these are the logs.
Could you mix those together, or would you not?
You mean
right, so like this doesn't look like those values were moved into the results array. How would we do that and log what the string elements are?
Great question. Yeah. So yeah, whenever you're doing console log, it's not going to do anything, any work for you. It's just going to output whatever you give it. So what we would do is if we wanted to do both, we could just simply run multiple lines. So like, hey, I want to log this, and I also want to do this work. This will do both. It will log everything, and it will push them all into this array.
Does one have to go ahead of the other like it does in a result or whatever, because it would finish early?
Oh, great questions. Like you're saying, like a return or something, or
right? Yeah, because if you return it, anything below the return doesn't show. So do you have to do that one in order, or does it matter?
Yeah, so it really depends. It depends on what you're doing. Like what you'll see, for instance, it depends on also what you're console logging. Like if I was console logging the results array here and here, it's going to be different. The first log will be whatever it was before this push, and the second log will be after the push. So like it kind of is dependent on what work you're doing and what you're trying to see. So this is actually one reason why one thing that's can be pretty helpful when you're debugging and troubleshooting your own code. Use lots of console logs, and you can put them all in the same value like this and see what happens to that value. So actually, let's go ahead and we can run this again. Now, if you recall, this results array is a constant. It has values in it. So I'm going to have double the values because I'm just going to keep pushing stuff to it. So I'm going to go ahead and run this again. And now it's run 4 logs because the first time it ran here and it's like, okay, that's the original array. Nothing's happened. The second time it ran here, now it's run the new, the original array plus that first one that matched. And the second time it loops that this condition is met, it's going to output whatever the loop was, whatever the array was before, and then again, what the final value is at the end here. Does that make sense?
Why are we missing the yes from results 2 and 3?
2 and this, you mean this one? Oh, these two, yeah. Yeah. So I'll maybe if I'm not sure if I can clarify it, but basically it's because actually I don't know what to do. I'll say before change and after change. If I just rerun this real quickly, I'm going to get another a little bit more, but actually, you know what I'll do? Results array equals, I'll just reset it. Oh, no, I can't. Dot, here, I'll show you a little shortcut, length equals 0. Hey, it's an empty array now. Okay, so I'm gonna run this again. We'll start over and we'll do it one more time to get back to where we were. So here's where we were before. These console logs are calling before and after the actual work we're doing on the results array. So when you first call it, it's in the original state. It just has these things in it, which is here. On the after change, it's going to have the first element we pushed in, which would be high. When it loops, so that's like the first loop that the condition is met. That's when high is the value in the another array example. But then on the second time it loops, this is still that same, the results array is still unchanged from the last loop. So these are actually the same value. They're the same thing. Only until you run it, the work again, does this array log the most recent, the final version of it.
Got it. Okay. So seeing right above, like the first time that you ran this after you cleared everything out, that makes sense too, that we're just seeing high and then it's adding yes.
Yeah,
so it
yeah.
doesn't add high and yes at the same time.
Right. Yeah. They're different loops. Yeah. Yeah, they're different loops. If we wanted to do like a slight modification to this, we could say, what happens if we do number? So now it's going to be it's only going to fire this condition if there's a number that the array has. So let's go and we'll reset this array again to 0. And if I run this loop, I will now get all the numbers. So if I say results array, I'm going to get those first 3, which are just these 3 here. Any other questions about loops? Okay. So the last thing I want to talk about is it's also loops actually, but it's nested objects. So we talked about nested arrays. Now I want to take a look at some nested objects. So here we have a more complex object than we saw last time. And you can see that just like arrays, an object can contain other objects. They also can contain other arrays, and arrays can contain objects as well. So like you can get as deep as you need And what's great about these is they really get representative of actual real life things. You can have, like for instance, a movie represented by an object that has title and film and date and actors, and have a list of actors, for instance. So you can really get like representative of whatever you can think of. If you have data values that thing has, it can be stored in an object. So in this example, we have like a title that we just created, this title for this object, and some data. If I load this up in Node, so we know that we can get things like, with a dot notation, like title, and there's the title. If we also try to get data, we just return the object that's inside of it. What if we wanted to get this value out of it? How do we get that using dot notation?
You just put an extra dot for example array, right?
Yeah, exactly. So you can say dot object2 dot data dot example array. So just like the square bracket notation, you can stack these, because again, what's happening is that JavaScript is like, okay, this evaluates to that object, and this evaluates to the object, the actual value of data, the key data on this object. And then all we're doing is that data thing is this thing. And so we're just adding another dot notation on top of it to be.
Can you use bracket notation the same way here?
Yeah. So
bracket data.
Yeah. So in this case, we have to do the string, right? So we'll do,
okay.
There's the array, the object inside, and example array. And there's the array. And of course, we can go even deeper and say 0 and get the first element of that array in that object inside the other object.
So why would you bracket instead of dot?
Well, why would you?
Yeah.
Again, it's like sort of like it's really mostly use case. So like if you could write an abstract function that does like goes through all of everything in object data and gets all the keys and finds the keys, similar to what we saw in like our loops. We might want something that's like go and get a particular abstract thing, or from I'm trying to do a good example for you, but basically bracket notation just means like you can either be explicit like this, or you can be a little more abstract. Whereas dot notation, you have to like refer to the thing that it's called. Good questions. So the last thing I wanted to show was this other type of loop. There's actually a few different types of loops for JavaScript, but this is one that's very handy for objects. So we have here a different type of for loop. This is a more modern version of the for loop in JavaScript, where we actually are just saying for and in are the two sort of special reserved words. And what this does is it's saying we can pass an object and it will actually get the keys for the object in this structure. So if I run this function here, this little loop here, I'm going to get the keys, which happen to be title and data. Now, if I wanted to, what if I wanted to get the keys inside of data, inside of this nested object? How could I modify this loop to get those keys?
With an if statement?
You could do that.
Yeah.
There's a more direct way, though. Can anyone think of it?
Just put some more brackets in. Yeah.
I think someone had it. Sorry, you both spoke. What was that?
I said key dot data.
Close. Well, in this case, though, since we're logging key, title doesn't actually, and data are the keys themselves. So actually it would just end up being title.data and data.data. So we don't do that. What we want to do is we can actually just we can go directly to data like this, or even dot notation. You can say, go in one level down to this object that we know, this key that is referring to this object really, and get all the keys inside of that nested object. So now if I run this, it's going to give me ID and example array, which are the 2 keys in here. I'm going to give you another one. Let's go back to just object again. How, given this structure, how could we get the values of these keys? So we have for every key in this object, we want these values. How do we do that given this structure?
And you exchange value for the word key?
Good guess. No, it's a good guess. And honestly, there are some languages that are like, okay, sure. But that's going to be, because this is just a variable, it could be whatever we want it to be. We could call it beef. And run it, and it will still just output the keys, because this is actually the JavaScript saying this is what you want. You want the keys, right? Whatever you want to call it, that's fine. But that's why we just by convenience we call it key to make sure we know, oh, that's the key that we're working with. So
you add the brackets?
Yeah. Where do you add the brackets though?
Right after the key. No?
No, that's again like this thing. So we can't really get anything from this unless of course it was its own data value, it was equal to something. But we're actually like key is actually the string that's the ID, or effectively, or the actual key in the object. In our case, we want to go back and just do again some abstract square bracket notation. So we're saying, hey, console log this object, the value of this object at this key. Now, if you run this, we now get the 2 values that are equivalent to those 2 keys. So I'll do just a comparison. So now for every loop, we run 2 console logs. First one is the key, second one is the value. First one key, second one value.
Did you even throw in a type of in there? Type of key?
Sure, yeah. Let's do type of string. However, you could do something like say obj2 at, you can also give numbers. Again, not really recommended because you're working with an object and not an array that has indexes, but you can do it. It's a valid key. Now obj2 has this weird thing here. It's actually a string, but does this work? Yeah, it still doesn't work because it doesn't like it. It doesn't do this. It's still trying to think it's a number, but you can use a number, or a letter will also work, or a string will also work. But yeah, so I got a little off track. Now that we have 3 keys in here and they're actually different values. Well, actually, no, they're not different values because they're all strings. So that was not a great example. We could try something like obj2. What if we try this? Obj2 now has this object thing here, but it's also a string. It's a little strange, but that's not a great example. But actually what happens if we run, I'm just curious, if we do this now, we have 4 keys now, and they're all strings. So they've all been converted, even though we declared it an object, an empty object, and it was like, okay, sure. You want to assign that to weird? You got it. But it still turned it into a string. So now I'm not sure if we can even get to it anymore. Oh, we can. Isn't that strange? It still evaluates. So when we pass in the square bracket notation, it's going to turn this into whatever it is in string form, which happens to be this, which is a another quirk of JavaScript, but that will work, just like obj2 5 will work, even though it's technically a string. Strange, huh? Weird JavaScript things. What are the questions y'all have? Nothing?
It's a lot to soak in for me.
Right.
Yeah, for sure. I'm going very fast.
I'm just like sitting here, oh man, just the possibilities are endless, it feels like. And just knowing what to do and when is really the key, it sounds like.
Totally, yeah. And like ultimately that's one of the kind of liberating but also anxiety inducing things about JavaScript in general and programming. So you can approach the problem however you want. There's always basically an infinite number of solutions to any challenge. You could do this sort of login loop a whole 50 different ways in JavaScript. Ultimately sort of the measure in the long run is performance of like what is the most efficient way, or like the least data costly way to do something, or time, or the shortest amount of time to do something.
Battle of form and function.
What's up?
It's kind of the battle of form and function.
Yeah, exactly. And like a lot of, when you get to like building out bigger projects, a big part of projects is basically going through and restructuring it to figure out like how you might realize like, oh, I wrote this function in a really strange way. If I take out this section of it, it does the same thing, but it's now a little more efficient. So you'll do a lot of that sort of work of like realizing how you could write something better or more succinctly, or even sometimes it's not always about succinctness and like trying to be as short as possible. I could name this function, for instance, A, and that will work. But A is a terrible function name because I don't know what that does. Or like you could write this to, I really want to show you some advanced code. You could do something like, this is not that advanced. You'll learn this in like a few weeks, but that's a valid function. And that's actually defining an arrow function, which is a slightly different form of function. And it's assigning it to A. So I can still call this with A parentheses, but like that's cool. And sometimes you will have cases where it's like very helpful to have a single line like this, but this is very, doesn't describe what it is. And although it might be short and easy to maintain, like it's easy enough to read, it could be a whole bunch of stuff in here that you just would rather have a function that says this function does this and have it more spelled out in the code rather than trying to get it to be a small thing.
Like y'all were saying, a lot of this is so you have to write it so somebody else can read it, right?
Yeah, exactly. And like the sort of ideal state of coding is like it's self-documenting. You should be able to look at a function and be like, I can see what this does. And as you get into more advanced topics, you'll start to learn things like that there are rules about like common practice for syntax, and that's one of them is like you shouldn't have very large functions as much as you can avoid it. If a function, of course it depends, and you'll end up with very complicated stuff. But if you can have a function do a single thing and the function name actually describes what it does, this is a pretty ideal function. It will always do the same thing. You can see what it does very easily. If this is a function that was like, it started here and this entire thing was a function, which we can do something like, I mean, just for example, you can put functions inside of functions. That's fine. All of these now, since I've changed the brackets around, this bracket ties to this bracket. Like this is all one function now, and it technically is valid, but certainly not very helpful. It's like a whole bunch of junk in here. So this would be an example of like, I might want to refactor this. That's the term I was thinking of. And just something that actually makes sense or is more readable, for instance. Yeah.
Sounds like too, if kind of standards or industry changes happen and you need to go into your code and debug it potentially.
Yeah, that's often the case. Or like you might end up getting hired in a job where there's a bunch of legacy code, and like they've been they were writing JavaScript 10 years ago, and that code is still in use. There are so many better ways to write that code now, and more efficient, and like just in general easier to maintain ways to write it. Like that would be one thing you could do. Also, like in general, like refactoring it's a good skill to have. And if you're, for instance, presenting to an employer and you want to like show like, hey, I really know how to code, you'd want to, part of that is like, I know how to structure this in the way that would make me a good teammate for my peers, right? I want to be collaborative and be able to write. I want to show that I can write code that other people can use. Awesome, great questions. Any other questions? I just about at time for my half of this, but happy to answer any last questions.